we will explore aircraft performance and aerodynamics. Understanding how an aircraft performs in various conditions is crucial for pilots and aviation enthusiasts. We will dive into key factors such as stalls, air pressure, and the role of aerodynamics in ensuring smooth and safe flight. Let's get started. Let's start with aircraft performance. This term describes how well an aircraft can fly. It includes important aspects like speed, range, altitude, and load capacity. Understanding these factors helps us know what makes an aircraft effective in the air. Next, we have aerodynamics. This is the study of how air moves around an aircraft. It's a key part of designing planes that fly well. When we understand aerodynamics, we can make planes safer and more efficient. Now, let's discuss some basic principles of aerodynamics. Lift. This is the force that helps the aircraft rise into the air, created by the shape of the wings. Drag. This is the resistance that slows the aircraft down. Engineers try to reduce drag to improve speed. Thrust. This is the forward force produced by engines, which needs to be strong enough to overcome drag. Weight. This is the force pulling the aircraft down due to gravity, and it must be balanced with lift for smooth flying. Let's discuss stalls in aviation. A stall occurs when an aircraft loses lift, the force that keeps it in the air. This usually happens when the plane exceeds a certain angle with the air, known as the critical angle of attack. When this happens, the wings can't generate enough lift, leading to a loss of control. Stalls can happen at any altitude and may be caused by factors like flying too fast, making sharp turns, or sudden changes in the plane's angle. It's important for pilots to understand stalls. Recognizing the signs and knowing how to recover can help prevent dangerous situations. Here are the main factors that contribute to a stall. The angle of attack. This is the most significant factor. If the aircraft exceeds the critical angle of attack, it will stall. Airspeed. A reduction in airspeed can cause a stall if the angle of attack isn't adjusted accordingly. Weight and center of gravity. A heavier aircraft or a center of gravity position too far back increases the stall speed. Aircraft configuration. The position of flaps, landing gear, and other configurations also impact stall speed. Turbulence. Gusty air can disturb the airflow over the wings, contributing to a stall. Let's discuss on bank angle in aviation. The bank angle is the tilt of an aircraft when it turns. When a pilot wants to change direction, they use a bank angle to help the plane turn smoothly. By tilting the wings, one side generates more lift than the other, allowing the aircraft to turn while staying level in the air. Using the right bank angle is very important for safe flying. If the angle is too steep, it can cause the aircraft to lose lift and lead to a stall, which is when the plane can't stay in the air properly. Now, let's explore the forces and pressures that play a role in an aircraft's performance. Lift and centripetal force. Lift is the force that keeps the aircraft aloft, while centripetal force is important for maneuvering, especially during turns. Induction drag, also known as inlet drag, is a type of resistance that affects an aircraft as it moves through the air. This drag happens when air enters the engine and other parts of the aircraft, creating disturbances in the smooth flow of air. If the inlet, the part where air enters, is not designed well, it can increase drag, slowing the aircraft down. That's why having an efficient inlet design is so important. It helps reduce induction drag, which improves the aircraft's overall performance and fuel efficiency. So, to wrap it up, understanding aircraft performance and aerodynamics is key to safe flying. From avoiding stalls to managing air pressure and lift, pilots must be aware of how these factors interact at different altitudes and speeds.